thanks. Thanks for the introduction. You kind of made half my pitch already. So yeah, in my knowledge, Jenkins kind of sucks. And to a lesser extent, GoCD and all the others out there do as well. Hi, I'm Florian. I'm a software developer, and I do software development and infrastructure coding at ThoughtWorks. And when you become a consultant, the first thing they tell you are the magic words. It depends. So let me kind of walk back what I just said. Does Jenkins really suck? Do all the other tools out there? Well, it depends. It depends on your project. It depends what you're trying to do. Maybe you figured these tools out. Maybe you know all its kinks and all its plugins, and you know exactly what you need to do to get done what you need to get done. Maybe then those tools are fine enough for you. Maybe you've managed to reduce the complexity of what you're doing so much that any tool will do. Maybe those tools are great for you. But maybe they aren't. So think back about the last time you broke the build trying to change the build. Think about the last time your colleague broke the build when you wanted to change it, and how you hated him because it blocks you from working. And think about it. Was he able to roll back his change? Did you have version control for your builds? That is possible, but a lot of people don't. And if you're trying to do that, it's not entirely simple to do. Have you ever thought, well, we do software, when we write software, we test it on our local machines, right? We write unit tests and integration tests and all that kind of stuff. Yet when we change our build, well, we just push it out there for everybody and hope it works. I've been in all these kinds of situations in big projects where there are 300 people working on a particular piece of code, where you have multiple teams out there. They all write different software, they all write different systems, and they're all very different, but they also have to conform to standards. So reuse comes into the picture, and consistency comes into the picture. So with all that in mind, and after one painful morning at the project, trying to figure out why my build was working the way it was, and why it was really doing the wrong thing. It was deploying to systems it should never deploy to. And after spending a morning just trying to figure that stuff out and ranting about it, we were sitting at lunch and we were thinking about what is it we would actually want in a build server. We'd want something to manage the complexity we just inherently have in our build service. We want to have something that's easy for us to understand and to reason about, that is easy to maintain, that is under version control, because DevOps told us that we should version everything, right? And that we don't. That supports reuse, and that supports testing. And we were just tossing ideas around, and we think, well, when it's supposed to be versioned, it should really be a text-based DSL or something, right? And we were thinking about how hard that would be to build something like that. That was right around the time when I came back from Clojure in 2014, and I was hearing Tom Hall speak, talking about escaping DSL hell by using parentheses all the way down. And this was his conclusion. He said that, well, maybe you don't need to build a new language. And even if you do build a new language, it'll probably be rubbish, at least for a while. And you won't get the power and reach that you're hoping for. And instead, he was saying that you should embed deeply into Clojure. So an idea formed in my mind, like, we have these tools ready. We have a tool out there that is flexible and powerful and maintainable, and that just naturally supports tooling and testing and version control for us. Those tools are programming languages, right? One of those tools is Clojure. So would it actually be possible to build pipelines completely in Clojure code? No configuration UI, no XML configuration, just code. Will that be possible? So I started experimenting, and the result of those experiments is now a little Clojure library called lambda-cd, which does exactly that, which gives you all the little building blocks to allow you to build your own build server. There is a small Clojure-based DSL in there, and we know Clojure is a Lisp, and what is that DSL? Well, it's a list of functions, not much else. There's an execution engine that can call functions, and there's some API and UI, so you can interact and deal with your pipelines. And there are all the little building blocks you typically have in a build pipeline. Interacting with the version control system, calling stuff on a shell, a little button to click to trigger your build, stuff like that. But maybe I should just show you instead of going on and on about what this thing could do. So let's build a build pipeline. And since our build pipeline is code, we need a project, right? How do we build projects? We build them with our favorite build tool, right? And this generates a little Clojure project for us. And we can see, OK, there's not much magic there. But remember, we have tools now, so let's get rid of the terminal. Let's use an IDE to work with our build pipeline. In my case, I like IntelliJ for pretty much everything I do, but if you prefer Emacs or something else, that's obviously also just as fine. Make that bigger. So what's in that little project we just saw? There's your Linear configuration. It has a dependency on my library. And there are a few source files in there. That's maybe not too exciting. We wired it all together in a main method. And then there are two files, just because I like the structure, not because it has to be that way. One to define the structure of your build, and one to define the build steps themselves. Structure of your build, OK. Apparently, we wait for someone to trigger the pipeline. And there's a step here. There's some steps that run in parallel. Then we wait again. And then there's another step in here. So what do build steps look like? Build steps are normal functions. While not quite normal, they need to adhere to a certain contract. That is, it needs to take two arguments. One is to pass data between build steps. The other one is to interact with the internals of lambda-cd, which is normally something a library would do for you. And in the end, you need to inform lambda-cd what was actually the result of that build step. Was it successful or not? Normally, you don't write that by hand, but you use one for built-in library functions, like this one, to call something on the shell. So a list of functions and the functions themselves. So we have a Clojure project now. Let's try to run that. I'll just take a second. OK, that seemed to have started a server for us. Let's have a look at that server. Let me expand that. Oops. And you can see this is pretty much the structure you saw before. There's your trigger. There are a few build steps. So let's try running that. Wow, green. OK, that's nice. Let's try the next part. OK, that one failed. And we can click on it to get a bit more details. OK, it's telling us it's failing. So that might be interesting. But why? Let's drill down a bit more. OK, the exit code seemed to be 1. That's why it was failing. So we've just written a bit of code. We've created a new project. And that project gave us a complete build pipeline. And now that we have that piece of code, we can do what we normally do with that code. We can version control it, we can test it, we can deploy it into whichever environment we want to deploy it in. You might already be convinced by that, or you might be saying, okay, but I could have clicked that together in Jenkins in 5 minutes. And you might be right. So let's drill a bit deeper into what you can do once your build pipeline is code. I've already talked about this. Tools are great. Not just because they can help you run your build, but also because you can now version things independently. You can create libraries. Think about someone forces you to adhere to a certain standard. Everyone in the company needs to deploy in the same way. We can have huge discussions about whether that is a good idea, but this is sometimes what we have to deal with, right? And we usually have some way of doing that, but usually those are a bit hacky. But now your build is code, right? So let's pull that out into a library. Now we can have a version dependency on our deployment structures. You might be starting to do microservices now. So you're no longer setting up a new system within your pipeline every year or so, but maybe every month or every week. And you might already have a template to create a new service for you. So wouldn't it be nice to also have a template that creates the pipeline for that? Yes, it would. And if you have those two templates, you can actually go from nothing at all to a completely integrated system deploying into your production environment within a matter of minutes instead of a matter of days. But it's not just tooling. This is a little piece of code I found in a team that wanted to experiment with continuous deployment, but they were a bit scared. They only wanted to deploy to production when there was someone in the office who could help them out in case everything breaks down. So this is the piece of Lambda CD code they wrote for that. And Junction, this little piece of code here that says, if we're in business hours, deploy, otherwise please wait for someone. That is now part of Lambda CD. It wasn't back then. So you can actually now create structure and control flow in your build pipeline with just an additional piece of code. Which piece of code? Well, that's pretty much all of it. And once you filter out the noise that comes with having to interact with the Lambda CD itself, there's actually not too much happening there, right? Well, we call a condition step. We look at the output of that, and then either call success step or the failure step. It's a function that, well, that returns a function, and if you look closely enough, that function looks kind of familiar, right? This is pretty much the same thing you saw before. This is a function that returns a build step. Why does it return a build step? Well, let's look at another example of how such a structure would look like. This is a nested list of functions. And once you evaluate that, well, inside out, the inner one returns a build step that's being passed to the next function that returns a build step. And suddenly, your structured nested list just collapsed to a simple list of functions. And I know how to deal with a list of functions. I can do that. But not only that, it also works in the reverse. And why is that nice? Because not only is your code data, not only is your data code, your code is also data. And I can transform that, for example, to render UI. But not only that, I could just as well use that to build more pipelines. Your build pipeline is code, but your build pipeline is also data. So you can do everything you normally do with data. For example, in this case, oh, I have this pipeline structure, but actually I don't want one pipeline. I want 3 of them for the 3 projects I have. But they should all check out a different repository and maybe call a different kind of thing to actually test things. And we generate pipelines with the function, and then we just map over the data we have, and suddenly we have 3 pipelines out of 1. So, what do I want from you in the end? Do I want every one of you to ditch your Jenkins instances tomorrow? Well, probably wouldn't be the worst of ideas, but that's not where I'm going. I just wanted to show you a bit what is possible and how you can use powerful tools such as Clojure in very new ways. And in the very end, maybe I want you to stop clicking around in your configuration UIs and start coding your pipeline. That's it. Thank you.
I can imagine there are questions.
Thank you for the presentation. I think my question is a bit related to, there's like a huge ecosystem of plugins and extensions for Jenkins. Can you talk a little bit about if you have support for this in Lambda CD, or how easy is it to extend it, or if that's not a problem at all that you foresee? Thanks.
Yes, so the plugin environment for Lambda CD, as you might imagine, is not as big as Jenkins is yet. 2 things I want to say about that. I think one, the plugin environment for Jenkins is also part of the fact that you have to work around so much to make Jenkins work in the way you want to work. For example, Jenkins just by nature doesn't support build pipelines, so you have a whole ecosystem around how to actually get build pipelines into Jenkins. You don't need that too much here. But yes, you can absolutely create your own plugins to do things for you and to simplify things. So at the moment, and it's not too hard because you see it's already code, so adding a bit more code or extracting a bit of code into a library that does things you find interesting is not too hard. There are already a few libraries. For example, there is one library out there that swaps out the persistence mechanism, which is normally writing to disk, to instead writing to MongoDB. There's a plugin to extend Lambda CD with CC tray, so you can add it to your build monitor. Otto, I think, has written a plugin that makes it possible to deploy into Mesosphere Marathon. There are a few things in there, and it shouldn't be too hard to write plugins or to use plugins that are fit for you and what you want to do.
Thanks for the presentation. I have a very stereotypical question. How does it scale?
Scale in what sense?
Like, because my understanding is that you use it every day, and I'd like to know is it also usable with bigger infrastructures?
Yes, I would say so. I mean, I would say it's more scalable than your typically built pipeline, just because you have all the power of your programming language to create new abstractions or create new libraries. And apart from that, I think I would usually use it in a slightly different context. So I wouldn't create one big build server that's there for your whole company, but I would create separate services for the different things you want to do. So you might want to have one Lambda CD instance for each project or for each team or something like that. Does that answer your question?
Yeah.
Thanks. Yeah. So do you have some examples of how would you sort of link a flow together? So say you have a bunch of microservices, you've got a build per project. How does Lambda CD provide any support or try to influence the ways that those artifacts would come together and form larger or ongoing pipelines into other environments? Or
maybe 2 things on that. One is you could probably, so I've seen people do that, create one big pipeline out of fragments. So because a pipeline is essentially a list, you could create different sublists and concatenate them together however you like. Problem with that is that in the UI it gets very long. So the alternative, I would say, is create a set of smaller pipelines and have the different pipelines just wait for an event, for example, wait for a new artifact in your artifact repository and go on from there. Those are probably the two ideas I have right now. But I think that most teams I've seen are normally working with a longer pipeline at the moment. And I think when you look at things like that, features like the aliasing and the run here gives you the opportunity to kind of group different build steps together, and you can collapse them in the UI. That helps a bit when you have longer pipelines because you're looking at the collapsed parts usually. But yeah, I'm happy for ideas on how to do that better.
No more questions from the audience? Maybe I can ask one. How do you handle slaves and credentials?
Slaves?
Slaves, yeah, multiple build slaves, different architectures, and credentials to access Git repositories or deploy to machines, whatever.
Both things I'd rather not even handle in Lambda CD. I mean, credential management, I think, is something that's really specific to the environment you're working in, and which is normally something you already have an idea about when you deploy an application. The application usually has credentials, and Lambda CD is another kind of application. So you would usually handle the credentials for Lambda CD the same way as you would handle the credentials for the application so you're building normally. I'm getting the question a lot, can you distribute Lambda CD across machines and different agents? I have a few ideas on how to do it, but I think I wouldn't want to build my own distributed system and my own kind of agent ecosystem, because I think there are already technologies out there that are just general purpose cluster managers or something like that that you can harness. So one project I'm working in right now already has a Mesos cluster running. And we're thinking about just having a small Lambda CD plugin that spawns build jobs on that Mesos cluster and let Mesos take care of the cluster scheduling itself. If you need that, for example, to run Selenium tests, then there's Selenium Grid or something like that. So I'd probably try to offload as much with the already existing methods to offload data and not put that into the library itself. Does that answer your question?
Yeah,
all right.
It does. I would like to point out that, I don't know if you followed the Slack discussion yesterday on the recording of the tracks. And yesterday the state was that we would record 8 out of 9 tracks in this hall, and Florian's was to be left out. But thanks to our video recorders over there, they just gave us this talk for free, so maybe say thank you. Thank you.